Hi there, my name is Banky Kichpanich, and the topic for my research paper was data mining in video games. So, in the past 30 years or so, video games have become very important to our culture. They can be found just about anywhere, they're enjoyed by all kinds of people, and some people even make a job out of it, which is something we call esports nowadays. And with this boom in popularity comes the rise of online games, which allows us to play with our friends and family without having to be next to them. And just like any other popular website that we use, such as Facebook, Twitter, Instagram, video games can be data mined just in the same way. As I mentioned before, game data mining works the same way as it does in any other context of data mining, which is looking for patterns in data. In a video game, this data would be something like the average amount of players at a certain time, or the rise and fall in quality of server performance of an online game. And normally, some sort of analytic system is placed in the game to record this data. This raw data is referred to as game telemetry. Now, people usually get game telemetry mixed up with another term that goes by the name of game metrics. Telemetry is the raw data collected from a game, while metrics are a measured quantity of telemetry data and give the data relevant meaning. For example, telemetry would be a user's playtime of one session of a game, and the metrics would be something like average playtime per player. Game telemetry is super important to a genre known as massively multiplayer online games, or MMOs for short. These games allow for massive amounts of players to play simultaneously and is one of the most popular genres of video games today. The reason that telemetry and metrics are so important for the genre is that these games must occasionally be patched. In order to do this, the servers that hold these massive amounts of players must temporarily be shut down. Data mining can be used to find the best times for these shutdowns to happen in order to cause minimal disruption to players. Data mining is used in the video game industry for several reasons. This includes things like finding ways to spot players that might quit the game, discovering flaws in a game's design, or seeing what parts players skip over or play the most in the game. But perhaps the most important reason for data mining in video games is probably monetization. In almost any game nowadays, players can spend real money to achieve in game items. These in game items typically offer paying players an advantage over those who don't pay. These purchases are referred to as microtransactions. Developers can use data mining to see what parts of the game are difficult for the average player and use that to come up with a way to incentivize them to purchase the items. So, for those MMO games that I was talking about earlier, they usually have a monthly subscription fee attached to them. When data miners are analyzing these types of games, they often look for ways to answer the question of how the developers can maximize these subscriptions. Usually, they look for what they call the most valuable players. These players are most likely to continue their subscription. Usually, they will return after putting their subscription on hold, and they have the most pull when encouraging new players to subscribe to the game. The developers can then tailor the game in order to cater to these players. When it comes to tools to data mine video games, they fall into various categories, including monetization, error logging, engagement, and many others. There are even some tools out there that combine all of these categories into one. Often, these tools will follow a structure of key features that should be included in a good analytical program. The first key feature is user segmentation. Generally, it's not smart to lump all players into one giant group because all players of a game will not play or experience the game in the same way. There's also the aspect of difficulty and skill levels. Some players may find the game more challenging than others, or just may flat out not enjoy the game as much as others. This allows developers to cater parts of their game to the most valuable groups. The next key feature is key performance indicators, or KPIs for short. KPIs are the metric by which developers can use to see if the game is being played to their standards, and are represented by in game events. For example, the in game event could be a big hole in the floor in which the player must jump over, and the KPI would be if the player successfully clears it or not. A/B testing is the last key feature, which is basically a decision tree test where you have two options and several tests are run to see which one results in a better outcome. For a relevant video game example, A/B testing could be applied to two versions of an item in an in game shop. For instance, say the item was a sword that granted the player with extra power. In one version, the sword costs 20 gold and gives the player an extra 3 points of power. The other version of the sword costs 40 gold and gives the player an extra 6 points of power. A/B testing would be used in this case to see which version players would have preferred to keep in the shop. When it comes to methods in game data mining, there's a few most commonly used methods, the first one being descriptive data mining or explorative data analysis. This is referred to as EDA for short. EDA is a method that examines graphs to find patterns or trends in data and is useful for basic analysis of data and understanding the patterns before applying any algorithms to the dataset. For example, you could have a bar chart that plotted a character class like a warrior, wizard, archer, or what have you, and their level versus the playtime per level, and you would see which class progresses the fastest and the slowest. Classification is another method, and it's a classic data mining method in general. Classification aims to organize data into categories or classes. This method predicts outcomes based on a training set, which is based on actual known results. This is especially useful for games with subscription fees, as classification algorithms can be used to predict if a player will continue to subscribe to the game or not, based on their behaviors. Association is another classic data mining method, which aims to find features or attributes that are associated with each other in some way, and defines association rules based off of that. These rules have two different criteria associated with them: support and confidence. Support indicates how frequently an attribute occurs, while confidence is the probability that an attribute occurs when another one does. And for example, if a large number of players bought an item A and a majority of those players also bought an item B, the following association rule could be made. If a player buys item A, then they will also buy item B. Clustering is a method that deals with segmenting data into separate groups and is similar to that of the classification method. The goal is to cluster them in groups so that the data within clusters are similar to each other, while the clusters themselves are not similar. These clusters could represent things like players, assets, items, scores, or anything of that sort. Prediction is another method that is similar to classification, but it's focused on predicting possible future values. It too uses a training set of known values to predict outcomes, but the training set is typically larger than that found in a classification method, as the most accurate prediction of future values is desired. Many approaches can be used for prediction, such as classic statistical methods, neural networks, decision tree analysis, or k-nearest neighbor. Prediction is most effective in online games, where successfully predicting the effect of design changes or how players will behave in certain situations can make the game more profitable for developers. Now that we've discussed these methods, let's explore some used in real games. The game shown here is Overwatch by Blizzard Entertainment, and it was released in May 2016. Overwatch is a 6-on-6 team-based shooting game and has tons of different characters. These characters are meant to serve different purposes on the team, such as healing teammates or just dealing damage to enemies. A group of data science students from the University of Manitoba and the University of Trieste set out to create a data mining algorithm that would provide a better understanding on how stats from these characters and player performances are related to win rates. The students chose to study a character named Zenyatta, who is pictured in the lower right of the screen. Zenyatta is a support class character, which means his primary role on the team is to heal teammates. The students chose this character because he cannot handle as much damage as other characters, a counterbalance to the fact that he can heal his teammates, and also the fact that he has a higher skill requirement than other characters. This makes it easier to separate the amateurs from the experts. The students then used clustering to see which traits led players to higher win rates. Since Zenyatta is a support character, the first trait that the team decided to examine was average healing done per match. In the diagram shown below, the clusters with the higher win rates are the ones that are highlighted. In these clusters, you can see that the average healing done per match was around 9,000 points. The group attributed this to Zenyatta's mediocre healing abilities and high damage output compared to other support characters. The slide does say low damage output, but it's supposed to say high damage output. My apologies. Because of this, they hypothesized that in the cluster plot for average amount of damage done per match, clusters with high win rates will place above average. As we can see in this cluster plot for average damage done, clusters with high win rates had values of average damage done well above the mean. The former hypothesis was found to be true, and their final hypothesis was players with higher win rates tend to heal less in exchange for more damage output. The next game we're going to look at is Tomb Raider Underworld. This game is a single-player adventure game in which the player must control their character through various levels containing various enemies and obstacles. These games can be very challenging to some gamers, as they require fast reflexes and reactions in order to avoid certain obstacles or enemy attacks. Professor Anders Draken from the University of York and Professor Alessandro Canassa from Northeastern University set out to study player behavior based on data collected from this game. The data included things like amount of in-game deaths, the ways that the player died, and completion time. Their approach involved using a self-organizing map, or an SOM for short. It works like a typical neural network that builds a model based on a training set, then applies that model to the actual data set. With this approach, the professors used metrics data from 1,365 different players, from which the SOM classified the players based on their behavior. The result was 4 different groups that covered 93.54% of the player sample. The first group was the veterans group, and they made up 8.68% of the classified players. They died very few times, they completed levels fast in general, and overall they just had a better than average performance. The next group is the solvers group, and they made up 22.12% of the classified players. This group also did not die very often, and they rarely used the in-game help system when it came to puzzles, hence the name solvers. However, they had a slower completion time than the other groups, which indicates a slow, methodical way to play the game. The third group was the pacifist group. which made up 46.18% of the classified players, making this the largest group of players. Their completion time was relatively fast while rarely using the in-game help system, which means they have some degree of skill when playing the game, but they also died more than the veterans and solvers. Taking that into account, combined with the fact that their deaths were caused mostly by enemies, the professors concluded that this group was not so great in parts of the game where enemies had to be eliminated, but were doing just fine in parts that required navigating past obstacles. The last group was the runners group, making up 16.56% of the classified players. These players died very often, but completed the game very fast, and also used the in-game help system frequently. These results can be used for developers to see if players are playing the game the way intended, which makes SOMs very useful for these kinds of cases. The future of data mining in video games is an exciting one, and I can only imagine the kinds of advancements that we'll see in the coming years. Thank you for your time!